For more than a decade, an increasing number of applications have employed embedded compute architectures that combine discrete ARM-based SoCs and FPGAs on the same printed circuit board. The analytics and control of an ARM processor, assisted by the massive parallel computing capabilities of an FPGA, have enabled companies to make giant leaps in innovation in a broad number of applications, from wired and wireless communications equipment and data centers to automotive driver assistance, medical, and factory automation systems. The growth and popularity of this device combination is the genesis for Xilinx's Zynq-7000 all-programmable SoC, which combines two 1 GHz ARM Cortex-A9 MPCore processors, FPGA fabric, and key peripherals on a single device. We proudly delivered the first Zynq-7000 SoC devices implemented in TSMC's high-performance, low-power 28nm process to customers in December of 2011, a generation ahead of our competitors. Today, a growing number of Zynq users are experiencing the true value of Zynq. It is far greater than the simple integration of an ARM SoC and FPGA logic in a single device. Zynq is the most efficient silicon platform for analytics and control, bar none. And for this and many other reasons, it is the smartest solution for next-generation designs. In creating the Zynq-7000 architecture, we put a lot of thought into how the ARM processing system should interconnect to the FPGA fabric, and also how and where the peripheral IP should connect to the processing and logic blocks. In short, we made Zynq's architecture ideally suited to the way you design. For example, since it can be quite costly and add latency to combine multiple 32-bit interfaces into a single 128-bit interface, we provide up to 9 32-bit or 64-bit AXI interfaces. As you know, most peripherals run at 32 bits or 64 bits, so this results in a more efficient FPGA design, which is a better match to the user designs than a 128-bit interface running on a single clock. Having the option of using 4 32-bit ports opens all kinds of creative design possibilities. It allows design teams to use several parallel transfers between the Zynq SoC's 32-bit ARM processors and its peripherals to suit their particular design requirements. It means you, as a designer, don't have to spend a vast majority of your time figuring out ways to navigate around the confines of the vendor silicon architecture. As a Zynq-7000 SoC user, you can implement your design intuitively the way you want and be creative. Today, Zynq devices are supported by over 20 operating systems. Zynq is supported by many flavors of Linux, including Xilinx's own PetaLinux, open source Linux, Wind River's Linux 5, and TimeSys Linux Link. Zynq SoCs also run on Android from IVEA, Microsoft's Windows Embedded Compact 7, and a dozen real-time operating systems, including FreeRTOS, Wind River's VxWorks, Greenhill Software Integrity, Aeneas OSE, and many more. We offer a full complement of operating systems that span the applications universe from communications, automotive, and industrial to consumer and medical. What's more, we already offer an ecosystem that is mature and thriving, while competitors are scrambling to catch up. As with all Xilinx devices, we ensured that Zynq-7000 SoCs offer the highest level of security and reliability. Xilinx has a proven track record with certifying and proving the encryption technologies at the highest levels of government, and is world-renowned for its radiation testing and qualification of its silicon for space and military applications. Today, our devices are in the Mars rover Opportunity and in the latest Mars robot, Curiosity. To ensure that the Zynq SoC delivers the highest level of security, we took several steps. First, we designed the architecture such that the processors boot first and the FPGA logic boots second. This ensures that if someone were to attempt to tamper with your design, there's only one path to tap into the booting code of the device. Next, we gave the device 256 kilobytes of on-chip memory, which we tightly coupled to Zynq's processing system. The memory is large enough that it can hold an entire OS inside of the chip, so that no external boot memory is required. If we had created an architecture that allowed the device to boot from FPGA logic first, or forced designers to use an external memory to boot the device, this would have opened Pandora's box and made the device much more vulnerable to tampering. What's more, if users would like to take extra precautions to shore up the security of their designs in Zynq, the device includes hardened blocks for AES-256 encryption, authentication, and RSA user authentication. Zynq platform IP will even erase or zeroize the device if it senses tampering. This encryption IP has been approved by top government agencies. The Zynq-7000 SoC also offers unmatched reliability. With a robust military and aerospace heritage, Xilinx is world-renowned for its SEU testing and creating FPGAs with the lowest fit rates in the industry. Xilinx is the only FPGA company that publicly publishes the fit rates of all its silicon. Because the Zynq SoC has been out for over a year, we have already performed extensive beam testing on the device to prove the device retains the low fit rates users have come to expect from Xilinx devices. To further ensure the robustness of the device, we took an extra precautionary measure by adding to Zynq's processing system a 16-bit error correction module that quickly corrects upsets if they do occur. Competing devices offer 32-bit ECC for the processor, but their implementation is inadequate because it doesn't support byte lane ECC. Holistically, the inherently low fit rate of its silicon and the 16-bit ECC make the Zynq-7000 all-programmable SoC the most reliable device of its kind in the industry.